Welcome to Create Robust Deployments for your SPA and API. Glad to have you with us. Here's the part where I tell you I'm definitely going to post the slides on my site tonight. You're going to go check on my site tonight, tomorrow, next week, next month. In about 3 months, you're going to get tired of waiting and you're going to email me. In about 6 months, I'll reply and say, no, I'm definitely going to post the slides on my site tonight. And I'll never post them at all. I've been in exactly this scenario and I don't like it either, which is why you can go to robrich.org right now and you can click on presentations up here at the top. And here's Create Robust Deployments for your SPA and API. It is online right now. Here's the slides that we're going to look at today. Here's the code already up on GitHub. It is right there for you to use right now. While you're here on robrich.org, click on About Me and you'll get to this page. Here is some of the things that I've done recently. I'm a Microsoft MVP. I'm a friend of Redgate. AZ Give Camp brings volunteer developers together with charities who otherwise couldn't afford software services. We start building software for them Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a give camp in your area, hit me up on Twitter or by email, and let's get philanthropy installed in your area as well. Some of the other things that I've done, SQL Source Control Basics, mine is Chapter 8. That was a lot of fun putting that together. I was a core contributor on the Gulp team in version 2 and version 3. And one of the things I'm particularly proud of, I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame. Now let's dig into creating robust deployments for your SPA and API. We talked about this guy. SPA and API. This is that question of how do I deploy my app? And in particular, not just the Docker 101 or Kubernetes 102 talk, but rather, how do I deploy my app and my SPA and my API? Should they be one container? Should they be two? Should I put them on one domain or two domains? That's exactly what we'll dig into. First, a little bit of level setting. Let's quickly go through the Docker 101 and Kubernetes 102 talks. Single page application. Now, what's really cool about a single page application is it's a whole lot more interactive than a regular website. Now, we don't have the same level of search engine optimization here, but we have a very interactive, a very fast to experience type of website where we only reload dynamically those portions of the page that we need at any one time. If we take single page application to its logical conclusion, then we can get offline support because the single page application runs completely in the browser. Now that's really, really cool. We have a run anywhere type of experience. An API. Typically this can be a JSON API, although it could be a REST GraphQL API, or it could be a SOAP API. But JSON APIs make it really, really easy to consume from a browser-based application because JSON is a subset of JavaScript that's running natively in the browser anyway. So we have this API that is serving interesting data in really elegant ways. It allows us to consume that data from any client. Maybe it's a SPA, maybe it's a watch app, maybe it's an Alexa skill. It can be anywhere. And that's what makes APIs so powerful is that the UI is separate from the API. The API just exposes data. So by separating the UI and the API, we get development and operational efficiency. If we need to overhaul the UI, maybe the API doesn't have to change at all, or maybe only slightly. We also get system complexity. Because the API and the UI are now separate, then we have some integration points, and we'll hit those a whole lot today. So deployment. How do I deploy both pieces? Let's explore Docker. Docker is a really elegant mechanism for deploying apps. It kind of removes that part that was really hard previously. We didn't deploy often because deployment was painful, but with containers, it is not. So what is Docker? Docker is an ecosystem around container virtualization. What are containers? It's lightweight kernel virtualization. Instead of virtualizing the hardware, we're virtualizing the kernel, the operating system. And so what is Docker? It's the suite of command line tools for creating, running, and managing containers. The analogy that I built here, what's the difference between AJAX and XML HTTP request? Well, technically nothing. XML HTTP request is the underlying technology that powers AJAX. But from a user standpoint, what's the difference between XML HTTP request and AJAX? Everything. XML HTTP request is the thing that powers right-click menus in Outlook Web Access. AJAX is the thing that powers Google Maps and Facebook and that app that you're going to build tomorrow. Docker didn't invent containers. Docker created a really elegant ecosystem around containers that allows us to use them really well. So I think as an industry, we're almost past this slide, but just in case, level setting. Here on the left, we have virtual machines. Here on the right, we have containers. On the left, I have my server. I have my host OS. Maybe this is Windows Server or Ubuntu. I have my hypervisor. Maybe this is Zen or VMware. And then in each spot, I have a virtual machine. I'll start by installing the operating system. I'll install the application dependencies. And finally, I'll install my application. If I want a second copy of my application, I have a second copy of the operating system, the dependencies, and finally my application. By comparison, here on the right, I have my same server. Maybe this is an HP or a Dell. I have my same host OS. Maybe this is Ubuntu or Red Hat. And then instead of the hypervisor, I have a Docker hypervisor. It's doing that same sandboxing, that same virtualization, that same containerization, that same containment of those processes. But instead of virtualizing the hardware, we're virtualizing the operating system. So then I just install my application dependencies and finally my application. I don't need another copy of my operating system. So we can see that, not built to scale, but we can see that we automatically get some operational efficiency because we're running in containers. We have a whole lot more space to run our business logic and a whole lot less space occupied by duplicate copies of the operating system. Now, because we're virtualizing the operating system, we do need a container runtime environment that matches a host environment. So for example, if I'm running a Linux container, I need to run it on a Linux host. And if I'm running a Windows container, I need to run it on a Windows Server host. So what's missing here? Well, what about Red Hat and Ubuntu? Can I run an Ubuntu container on a Red Hat host? Well, yes, because we're virtualizing the kernel. We're not virtualizing Ubuntu. We're virtualizing the Linux kernel underneath it. So an Ubuntu container is still the Linux kernel, but a Windows container is not. So a Windows container needs to run on a Windows server host. Well, what else is missing? Well, Mac. Here we're talking about Linux and Windows. How do I run Mac containers? Well, Mac is not Linux. Mac is Darwin BSD. And yeah, Docker is not really built for Mac. We can virtualize containers in the same way that we virtualize other things. And so we can do something like this. If I'm in development, I may have my Mac laptop or my Windows desktop. I'll install Mac or Windows. I'll install a hypervisor. On Mac, it's Xhive. On Windows, it's Hyper-V. And then into there, I'll install a guest OS. Let's call this Docker Desktop or Moby Linux. Then I'll install the Docker hypervisor into that Linux operating system, and now I can host my Linux containers. While I'm here, I may be able to host other virtual machines inside of this containerized environment. This is how I would run Docker on Mac or on Windows desktop. Now, when I'm running on production, I need to run here in the mechanism here on the right. That gives me maximum server density. But when I'm running in my development environment, this allows me to run containers that don't exactly match my host OS. So the next up is the Docker ecosystem. With containers, I start out with a Dockerfile, and this Dockerfile explains the steps involved in building my container. It contains commands to copy content into the container or run installation commands. That Docker file is that configuration as code that tells us how to build our container. We will build our Docker file into an image, and this is the binary blob that includes all of the details associated with our runtime. Now this image we can share up with others through Docker Hub or another container registry, and we can pull containers down from Docker Hub and use them in our projects. As we start up a container, we'll start up an image as a container. We'll put it on a Docker runtime, perhaps that's Docker machine, or maybe we're using Azure Container Service. And that Docker runtime will plug in Ethernet, will plug in power, and that image becomes a container. Docker, build to an image, run as a container on a Docker hypervisor. We can do the same process with many containers running in concert. We can have a Docker compose file that specifies perhaps many images on Docker Hub, or many Docker files, or some of each. We'll build up many images, and we'll run many containers on a Docker hypervisor. As we move from Docker to Kubernetes, we keep a lot of these same mechanisms. Kubernetes begins with, so you have a Docker container? And much of this Docker file and build, all of that process will carry over to Kubernetes just fine. Now in this case, in Kubernetes, we'll run a different Docker hypervisor. We'll run the Kubernetes orchestrator over the top of that. So we won't actually deal with Docker run commands directly. But both Docker and Kubernetes allow us to do this Docker file, build an image, run a container. So when we're doing our SPA and API developer setup, we'll probably do something like this. Now this is a standard Docker setup, or rather this is a standard SPA setup where I have my browser, I'll connect my browser to my SPA, and then I'll proxy certain portions of my SPA off to an API. This is that main mechanism where I can kind of do really fast developer experiences. Now this isn't in containers at all. This is just a browser connecting to the front-end SPA and proxying that to a back-end API. So let's scaffold out some containers, or let's scaffold out a SPA and API and ultimately Dockerize those. I have here some content. Let's make a new directory. Make dir demo, cd demo. Now we can start out by scaffolding out .NET new -- help. .NET new will allow us to quickly scaffold out a site in various ways. So web API or gRPC, MVC. So we could do something like this. .NET new web API -- name net API. That will scaffold out all of the content that we need to be able to pull this off and ultimately create a project. That's perfect. Net API, and now we have our content. Controllers, views, it's all ready to go. Or actually controllers, not views. We have our API. Okay, let's create our SPA. View, create web app. Now, as we start up the Vue create mechanism, it's going to do some interesting things. It'll actually interview us and help us choose the options that we need. I'll manually select some features, and I can choose to turn on TypeScript or progressive web app or add Vuex, the Flux store, or a SPA router. All of this would run client-side in the browser. Now, once I'm done choosing, it will ask me some additional things. And in this case, I've already created one of these. So here, there's the demo that we created. We have that net API, and we have the Vue app. Now, all of this is available up on GitHub right now. So we have here the net API that we scaffolded out, and we have a Vue app that is ready to go. npm install being what it is, this Vue app is already npm installed. So now when we're ready to go, let's go into Vue app. And as we look at Vue app, Let's open up VS Code in the root directory. As we look at the Vue app, I have made a few modifications here. Here inside the components, I've created a weather forecast view. Now this weather forecast view just shows some weather data. Our API has a default. And we're going to go do a fetch out to API/weather forecast. That's the weather forecast API that we've set up in our API. It'll go grab some data. It'll merge the date into place and ultimately show that data here in place. If this hits an exception, it will catch that exception and show it in place. Let's close these. So if we get an exception, we'll show the exceptions in place instead. I did create a vue.config.js that didn't come scaffolded straight away. And this just says, hey, if I hit /API/, then forward that off to localhost 5001. Localhost 5001 is here, this net API, where I'll hit this controller, this weather forecast controller. The only thing I've changed in this API is to make the API start with /API. So it'll do some interesting things. It'll simulate some weather forecasts and shoot those back down. The only other piece that I did here in the app is added the weather forecast component into our website. So let's start it up. npm run serve. That'll get our spa started up. I'll switch over to another component, cd to net app, or net API, .net run, and this will start up our backend. Our backend is started up, and it started both on HTTPS 5001 and HTTP 5000. It has an auto redirect, which is perfect, and our front end is running on localhost 8080. So now if we go here to our browser and grab localhost 8080, we have our weather forecast. This is all simulated data. It's mighty hot here in Phoenix, but we've got a great way, and as we refresh our app, we can see that we'll get these network requests. We'll go hit that API, we'll get that response, and we'll be able to render that content. No errors in our browser. That's perfect. So let's stop this and stop this. Now, how do we Dockerize this? Let's do exactly that. So first step in Dockerizing this, we will create a .docker ignore. Now this is not that unlike a git ignore. We have a git ignore here in our project, so we could just copy that into place. But in the case of this net app, we can ignore bin obj star.user star.suo.vs, all of the things that we don't want to go into our container. Well, here in the properties, there's also a launch settings JSON. We don't want that to end up in production. That's the details of how to start it up while debugging. To that end, we have this app settings.development.json. And so let's not copy that into the container as well. We've got our Docker ignore, and now these are all the things that won't go into our container. Next, let's create another new file, and this will be a Dockerfile. Now, it's important that this is Dockerfile and not Dockerfile.txt, but that's the perfect details that we need. A Dockerfile that specifies this configuration as code to get our content into containers. From, well, let's come out to Docker Hub, hub.docker.com, and we'll search for net core. Here in the net core repository, we see we've got .NET Core SDK, ASP.NET, runtime. Samples is great if you'd like to see lots of different types of Docker files. Let's pull up the SDK. Now this SDK says, here's that base image. That's perfect. From mcr.microsoft.com, .NET Core SDK 3.1, and I'm going to use the Alpine variant of that. I got the Alpine variant because I scrolled down and looked through these tags, And the Alpine variant is a lot smaller. So not that one, that one. Okay, we're going to copy in all the files from our host directory where we run the docker build command into the current directory in our container. Well, what's that current directory? Workdir is /src. That's our current directory. Next, we'll run .NET restore. We'll restore all of our NuGet packages. Run .NET build-c release. We'll probably run .NET test, run all of our unit tests. In this case, we didn't scaffold any, so that's totally fine. Run .NET publish-c release-o/dist. So we're going to publish all of our content into the dist folder. Now the concern here is that anytime we change any code, maybe an HTML file, maybe a JavaScript file, we're going to restore all of our packages. Let's do this first, because now we'll get all of the packages in place, and then we'll copy everything. Well, we still need to know what packages we need to copy into place, so let's copy net api.csproj into the current directory, and now we know what we need to restore. This csproj is that list of all of the packages. Then we'll copy everything else, and now if we only change some code, but we don't change the packages that we're restoring, then Docker will keep this cached layer. That's perfect. Copy. So now we would run something like copy this from /dist to /app. And then finally, cmd is the command that runs when the container starts up, and we'll say .NET netapi.dll. We'll need to copy in a few more things that will, for example, set some environment variables, expose ports, run in production mode. This just tells ASP.NET to start up on port 5000 and tells Docker that port 5000 is where we expect traffic to come in. Now this Docker file again will work just fine, but we're deploying our source code, we're deploying build tools. Really, we want only the content that we built here, only those built assets. So let's say we'll head back to Docker Hub, and let's go look for an image that only includes the runtime. Here's .NET Core ASP.NET. That's perfect. .NET Core ASP.NET. We'll grab that image, set that in place. Alpine. And now instead of copying it here, we will say copy -- from equals build dist into the current directory. Well, how do we get build? Well, build as build. Perfect. Now we have a Docker file that will copy in all of our content. It will run a build, get the built assets, copy them into a new container, and ultimately publish that new container that doesn't include source code. We could think of this as our build container and this as our run container. That analogy breaks down pretty quickly, but we're close. Okay, so we have our Docker file for our app. That's our API. We'll create a new .docker file, and we'll do all the things in Node that we don't want to copy into place. So we don't want node modules. We don't want package-lock.json. We could say don't copy star.log. That's probably pretty good. Similarly, now we want to go create a new Docker file. Docker file from node. I'm going to use the Alpine version again. And I'm going to copy in everything from my directory where I run the docker run command, or the docker build command, to the current directory. Where's that current directory? Workdir is /src. Perfect. Similarly, npm run npm run build. I know it's build because here in my package.json, I have this build mechanism right here. That's perfect. npm run build, but I want to do that similar thing where I want to copy in the manifest, package.json, and then run npm install before I copy in everything else. Now I'll get all of the content into place before I copy in all of the rest of the content and build. Once I've built this, it will output to the dist folder, let's say from node alpine, copy -- from equals build /src/dist to the current directory. Where is the current directory? Workdir is /app. And now, well, the cool thing is now all of these things are static. I don't need to run in Node. I could just run in Nginx. And an Nginx Alpine container is going to be a lot lighter weight. I don't have any of the runtime there. So now inside that Nginx container, I'll probably want a few more things. So I'll want to copy in an nginx.conf into the spot. I'll want a workdir inside where Nginx expects it to be. And now Nginx already has the CMD to start it off. We're ready to go. So the difference that we got from here from the 0 CLIs step to the 0 Dockerfiles for each step is we have that Dockerfile in each spot. We have the Dockerfile for our Node app, and we have our Dockerfile for our .NET app. We're able to use multi-stage builds to get everything in place, and so we're kind of running at maximum efficiency. That's perfect. Now the cool part is we just did a Docker 101 talk. That's cool and all, but now how do I get the two of them to work together? Well, I could do a Docker build in both places. Docker build -t net-api step 0 inside the net API folder. I could also go up to the Vue app folder and Docker build -t Vue app step 0 in that current directory. I've done both of those previously, and so if we say Docker image list, we'll see there is the net API. Oh, that's here it is, net API step 0. And here is the Vue app step 0. So now we could run both of those. Docker run I'm going to Docker, so what was that outside directory? Docker build -t Vue -app step 0. The outside directory is this, the current directory. That's perfect. Okay, so let's run both of them. Docker run the net API, Docker run the app, and so now we can go to localhost port 3000 and view our app. So localhost port 3000, F12 developer tools, and we see that we get an error. Well, what it's doing is it's trying to reach out to localhost :3000, and localhost :3000 is the Nginx app. It has no idea where that API is. Well, if we were to hit localhost :5000 /API/weather forecast, it would work just fine. We get all these temperatures. Well, so that's a disconnect. How do we get from here to there? Well, first off, Docker container rm-f. Let's stop both of these containers so they're not in our way later. Docker container rm-f. Those two containers. And that's kind of the basis of where we need to go here. How do we deploy linked resources? Should we have one container or two? One domain or two? So one domain, just put it all on mysite.com, or should we have mysite.com and api.mysite.com? Let's dig in and see. Well, the cool part is that it isn't just a binary switch. We kind of have lots of different pieces. Now, we can't exactly deploy one container across two subdomains, but we do have these three choices. A single domain could run on one container, a single domain could run two containers, or two containers could run on two different domains. Let's look at each piece and see how we would handle this. Let's architect different pieces. Ultimately, we'll kind of say, well, which one should I choose? And with each piece, we'll look at the pros and cons of that and be able to identify the different pieces that we need. Why should I choose each one? That's really where we'll focus. When does each scenario really make sense? So here's that Docker architecture design. When I have one container, one domain, I'll have a browser, it'll go to the internet, and it'll hit that SPA and API together in one container. Now this is really cool if I'm hosting something like on Heroku or Azure Web Apps. API adds the static. So how would I do that? Well, I add the API, and then in its static file hosting mechanisms, I will add the SPA into place. So a single Docker file will build both pieces, and the final step of that Docker file will copy the SPA files into the static folder of the API. So on a Node app, that would be the public folder. On a .NET app, that's the www root folder. So that's exactly what we're going to do. In development, we do exactly what we've already done, where we have the SPA and it forwards off to the API. So let's do that. Well, here in our app, let's pop open the one container, one domain folder, and here's that Docker file. Notice the Docker file is outside those two folders. We're going to start off building our .NET app. Here's the exact same steps that we had before. The next step is we're going to build our Vue app. Here's the exact same steps that we had in our Vue Docker file. The only difference in both places is I have to reach into the folder to go get those pieces. Now here's where the magic comes together. We're running inside of a .NET app using only the runtime. We copy in our built content into the dist folder in .NET, and then we copy our API content into the app www root folder. There is a few small modifications here inside our API as well to make this happen. If you're using .NET, then this is perfect. If you're using another host, then you'll need to do this in that mechanism as well. I'm going to use default files and use static files. Use default files will serve index.html for the slash page, and then use static files that will grab all of the things. So if I said /index.html or /js/app or all those things. The last piece that I have is this new SPA controller. If ever I load the page using any of the client-side routes, I need to serve the home page. And so this just makes sure that I've got that spot. All of the server-side, all of the client-side routes that I'll use, I'll return the home page from the server-side app. Once the client-side SPA boots up, then we're ready to go. So let's run this. A Docker build command in the host would get us to the spot where we're ready to go. And I've already done that previously. So I did Docker image list. I already grabbed, I already ran this build file and created this one container, one domain. Here's that SPA and API. So let's launch that. Not that. Let's launch this. Docker run will forward in port 5000, and let's fire it up. So we'll go to localhost 5000. The other :5000. There we go. So we launched our app on localhost 5000. And if we switch over to the network tab, we can see that then when we went to do this API request, we were serving into the .NET API. But when we did this main page, we loaded that also from the same container, and it just forwarded off the index.html page. So that worked great. Docker container rm -f. Let's stop this container. That was perfect. We got one container to do both pieces. We built the API, we built the SPA, and we combined them together so that the SPA was running out of the static hosting directory. Now, some might argue that this is conflating concerns, and I agree. We now have one site doing both pieces. But in places where we only need one site, when we only have a monolith API and a monolith SPA, then this can be a really easy way to deploy both of them to a single hosting without having to worry about all of the weirdness of getting two domains to work together. When would I use this? When I'm hosting on Heroku or Azure Web App, when I don't have an orchestrator, or my backend is a single monolith. Next up, two containers and two domains. So in this technique, our browser is going to reach through the internet to example.com to harvest our SPA, and reach around the internet to api.example.com to get at our API. Now, what are the changes that we made here? Well, we started again with our Dockerfiles for each. But here, when we're making a request in our component, we can't just make a request to /API. We have to make a request to this base URL. Now, in Vue, to get an environment variable baked into place, we do need to start it with Vue_app, which is why this is Vue_app_base URL. I have an env file here that specifies the details that I need to run locally. And I do have an end file with production that will specify my production details. And again, it's just localhost :5000 in this case, because I'm all running it from my demo box. But as we do a build, this URL will get baked into place. It must be baked into place because we're running this on the client's browser. And so we can't reach into an environment variable either running in Nginx or running in .NET because that runtime isn't there. The runtime to create this content already was created back when we did the Vue app build. So we baked that into place. The other thing we need to do is here on the server, when we start up our app, we need to do a similar mechanism to specify the CORS domains that we'll support. Now, a CORS header says, what can I do cross-domain? As the client first requests the API, it'll do an options header to say, hey, is this domain allowed to make cross-domain requests? And the API can respond yes or no. Well, technically it responds with this CORS domain header. So we're configuring this CORS domain header so that we can say, this is the SPA that is allowed to connect to this API. Now, this is technically a security thing, but this says nothing about securing our API. We still need an authorization story on our API. This is merely a first check in our browser to see if it works. So we'll rig our CORS domain, and then we'll be ready to go. So we have two extra pieces here. We have the CORS set up on our server, and we have the environment variables on our app. Now, because we have the environment variables baked into our app, it does mean that our containers are different in every environment, and that's unfortunate. Let's run these two. The two container, two domain setup. We have both of our containers running, our API on port 5000, our SPA on port 3000. And now if we go to localhost 3000, we'll see that we get at our backend. Ooh, did I get a failure starting? Nope, that's it. There we go. We had a cached version of the page. So we can see that we load the initial page from localhost 3000, and then we run the API request from localhost 5000. Now, this isn't communication between the containers. This is communication from the browser to the second container. And that's why it's the outside address to that API. So let's turn both of these containers off. Docker container rm -f. Let's grab that container. Docker container rm -f. That container. Okay. So the browser reached out to example.com to load this. In our case, it was localhost 3000. And then when the browser was ready, the browser reached out to the API, in our case, localhost 5000. These containers don't talk to each other. They just happen to be at the right place so that the browser can reach out to both. We did need that extra complexity of the environment variable and the course headers. And so here's that mechanism. The API has a whitelist of allowed domains. The SPA has a hard-coded API domain. The SPA app makes an AJAX request. The first thing is the browser will stop and make an options request. The API answers with the course header, and the SPA validates that course header. If that course header passes, then the SPA browser completes the real request. Here's that course header, access control allow origin, http example.com. So in our case, it replied with http://minikube:3000. And because minikube:3000 was on the list, then it could make that request to finish that domain. That means twice the traffic to do these requests to that domain, that API. But on the upside, those APIs are very separate. So this is great when we have a strong naming convention, when we have very different teams working on the front end and the back end. It's great when we need to scale the pieces very, very separately because we have different containers to be able to scale up and down for the different pieces. On the downside, there's a lot of complexity in this setup, and the images that we build for the front end have that baked in environment variable, so we can't just promote them to the next environment. Why can't we do this environment variable dynamically? Why can't we inject the content into the container when we run it? It's because the environment variable is here in the browser. The fact that this one has an environment variable set or this one has an environment variable set is not relevant. This is where the environment variable needs to be set, and this environment variable is set at the point where we build. So 2 containers, 2 domains. It's probably one of the more complex mechanisms. There's definitely a time and a place for this, and that's when we have very separate front-end and back-end teams. If we have a solid naming convention between the teams, then we can get a pretty elegant mechanism through this process. Well, how else would we do it? 2 containers in 1 domain. 2 containers in 1 domain is really elegant because we have both of those containers running in different places the way we expected. Example.com is our SPA, and example.com/API is our backend. What we put in front of it is this Kubernetes ingress controller. This Kubernetes ingress controller allows it to specify, hey, if you start with /API, go this way, and if you don't, go that way. The browser will reach out to Kubernetes. Kubernetes ingress will forward it one way or the other, and each of those containers can now scale independently. So in production, we'll do exactly that. We'll have our ingress controller, and because our ingress controller is in the way, there's not really any difference in the setup. The ingress controller does that routing to all the places. In development, we'll do that same mechanism. Our SPA will forward off to our API, and everything works. So let's take a look at this sample. Now we have some Kubernetes setup files here inside the 2 containers, 1 domain setup. Our net app is, our API is back to normal. There's no wacky startup mechanisms. There's no wacky CORS headers. There's no wacky environment variables. The content just reaches out in a very straightforward way as if it was running on the same domain, because to the browser, it is. But we have these Kubernetes files. And in these Kubernetes files, we have a deployment for our backend. We'd have this anyway if we were running in Kubernetes. We have our deployment for our front end that specifies the container or the image and the version, in this case, Vue app 2c1d. Similar, we have a service. Now this service will round robin across all of the instances of our pods running in Kubernetes. In this case, it's going to accept traffic on port 5000 and forward off to port 5000 inside the pod. The one piece that is new is this API, ingress controller. Now here in this ingress controller, if we were going to do it in production, we would add another line that says host example.com or whatever our URL is. But in this case, we're going to accept traffic on all domains. And here's the magic. If the path starts with /API, then go to net API. If the path otherwise, go to Vue app on port 8000 or port 80. So let's start this one up. CD to, let's go back to our main one. CD to 2 containers, 1 domain. And we will kubectl apply -f k8s. And k8s will actually go through and run all of the files in that directory, which is perfect. Created the ingress, created the deployment, the service, the deployment, the service. Kubectl get all and ingress. Here's our pods, they're already running. Here's our services, they're running. Deployments, they're running. Here's our ingress, and it's listening on all hosts, all addresses, port 80. So now if we go to our local host, if we go to localhost :80, now we hit the ingress controller, and the ingress controller will forward off to the 2 pods. Now we're loading our home page on localhost. We're loading our API on localhost /API/weather forecast. But if we look at our pods, we do have 2 different pods. Here's our API, and here's our app. And in this case, we have 2 instances of our app. We were able to scale that independently. So our ingress controller is really elegant at being able to separate those 2 containers running on a single domain. We don't have any hard-coded URLs. We don't have any weird CORS headers. On the downside, we do need Kubernetes. Now, Kubernetes may be standard in your infrastructure, but if you only have 1 container to run, 1 app to run, then Kubernetes is probably overkill, and you probably want to do that 1 big container instead. The other downside is that the entire backend must be on 1 subdomain. Well, we could do more granular things in our ingress controller to point /API/this thing in one directory and /API/this thing in another directory to another container. And that could be a really elegant solution here. But from the front end's perspective, the entire backend is running on a single domain. If that's a downside, then look to CORS headers so that you can separate those domains out. 2 containers, 1 domain is perfect when you have Kubernetes in place and you want your SPA to reach out to 1 API or 1 API gateway to be able to get at all of the rest of the resources. Kind of a bonus technique here, server-rendered SPAs. Server-rendered SPAs, you might have some of the SPA built on the server, and then that page, once fully populated, continues on the client. Now this server-rendered SPA is great for, here's how that works, is the browser will reach out to the backend, and instead of just serving a static file, it'll actually take a first pass through this, populating it with all the data. It'll forward that pre-populated page down to the browser, and the browser can continue on. This is great if we need search engine optimization. Here's some sites, some projects rather, that are able to do this. Next is built on React. Nuxt is built on Vue. Angular has Universal that does exactly this. And they're great for that mechanism where I need search engine optimization. On the downside, I need to be able to run JavaScript on the server. So these are best with a JavaScript-based server backend. So in our case, we were using .NET, and .NET has a mechanism for shelling out into Node apps to be able to do these universal renderings, but it's a little fragile. So if you're using Node as your backend, universal, these server-rendered SPAs may make a whole lot more sense. Oh, one of the other major downsides is that these universal mechanisms, these server-rendered spas, generally don't use the CLIs for the apps. So if you have a regular Vue app or a regular React app, it'll be a little hairy, which makes it a little bit more difficult to upgrade. So with a server-rendered spa, this is great for search engine optimization. I've kind of done all of my server rendering, and the first delivery to the client is a fully populated HTML page. So if my search engine is Google and it doesn't want to run the JavaScript, there's no JavaScript to run and it still gets content. So we took a look at all of the resources, 2 containers and 1 container, single domain and subdomains. As we look through this, 1 container on a single domain, we'll put a spa in the API's public folder. When we run 2 containers on subdomains, we have that base URL environment variable, we have CORS headers. And when we run 2 containers on a single domain, that's where we use a Kubernetes ingress controller. Each of these have their best spots, and so here's that one. So that's the magic question. Which solution is best? Well, it depends. If I want to run 1 container on a single domain, this is best when I have few microservices. When I don't have a whole lot, I don't have an orchestrator, I don't want the complexity of Kubernetes. Subdomains is great when I have very separate teams doing the front end and the back end, and I have a strong naming convention and don't want those concerns to overlap. When would I use a Kubernetes ingress controller? When I have many microservices and I want all of them to work together. In general, I choose a Kubernetes ingress controller when I have many microservices, and I use a spa in the API's public folder when I have few. This one is generally too complex for me, but is definitely a good solution. And you can use a server-rendered spa in this technique by putting the spa in the API's backend folder, but you will need some of the spas rendering in that public folder as well. You might also use a server-rendered spa with an ingress controller, where you can put all of the different pieces in different folders, in different containers, and use that ingress controller to route to the correct container. Thanks for coming to this talk. Reach out to me on robrich.org or tweet me at rob_rich on Twitter. Thanks. Bye.